Right, so next we're going to spend some time looking at the concept of population ecology. This is where we're dealing with populations. Population is a group of one species. When we talk about the population of Murray, Kentucky, we don't talk about all the dogs, cats, and people. We just talk about the people. And population is typically measured in a term called population density. And population density has to do with the amount of an organism, whatever it is you're measuring, per square kilometer. So here you can see the different population densities in the world, how some countries are extremely dense and others not so much. And some vary from place to place inside that country as well. One way to approximate population numbers and then population density is something called the mark and recapture method. These variables, by the way, I just kind of made up on my own. There's probably a better version of this formula somewhere, but it's still the same kind of idea. This idea that the estimated population size is, if you capture one group, which I've called G1, and you capture them and you mark them, and then in group two you capture and mark a second group, maybe a week later or whatever. There's going to be a certain number that you have recaptured in group two, and that's what the R represents down there. Now, let's say that if you captured 100 the first time and 100 the second time, and there were 20 recaptures, then you could approximate the population to be around 500. You get the idea. And so that's how they would do this. And then you just take that 500 and you think about the area that you're in. If this was over 50 square miles, and you would say that that's the density of that area. Organisms tend to disperse in one of three different ways. Organisms can be clumped. Clumped is where they group up. This is like our own species. We tend to clump in places called cities and towns, versus a uniform dispersion where everything has their own space. Penguins are a good example of this because they tend to space out regularly, even though they seem to be close together, they are. Where versus a random dispersion, which is like a forest full of trees. There doesn't seem to be any particular pattern. Random is hard to quantify. We have a hard time understanding random, which is why we tend toward a uniform or a clumped dispersal pattern. But random is something that can happen in nature. Now, when we talk about how populations grow and decline, we typically use the term demography or population demographics to talk about this. Growth happens from one of two reasons. Growth can happen from birth, and growth can happen from immigration with an I. These are individuals migrating into a population. But populations can also decline as well, and this happens from death, of course, the unsuspecting small bird being ripped off a limb by a larger bird of prey, or immigration with an E, exiting. Things are exiting the population, leaving. And so if you look at the birth and immigration as a single number and death and immigration as a single number, you can compare those two numbers to see if a population is growing or not. Usually tables like this called life tables can give you some indication as to how a population is growing or declining and some other things going on here. These types of tables are usually divided into groups called cohorts, and cohorts are just based on age, and they can be whatever depending on the type of information that's being presented here. As you can see here, these are the years, and there's all sorts of different stats you can get here with a table like this. Survivorship curves are often used to show a species survival based on the max lifespan of that species. And so species will typically demonstrate one of three curves. We are considered a type 1 species in that the percentage of individuals living to their max lifespan in our species is relatively high. As you can see, the curve doesn't really start to downturn until about 60% or so. And so a vast majority of our species live to an older age. Why is that? Well, we take care of our young, we generally take care of one another, and that's why that does this. Large mammals tend to be type 1 species. A type 3 species is the exact opposite of that. This is a species that has a lot of young with almost no parental investment, almost no social kinds of behaviors. And so the idea is have lots of young and maybe a few will survive into adulthood. And so very few reach that maximum lifespan. And the type 2 species, as you can notice, has a straight line. These are usually prey species. These are species that it doesn't matter what age they have an equal chance of dying at any moment. And this has to do with just the fact that they're food for some other animal. And then lastly, there are other types of tables called reproductive tables, and these are only concerned with females at reproductive age. And the reason here is that they are the only real individuals that will have a impact on population size since it's females that give birth. It makes sense. If there's a low number of females in a population, that may indicate that that population is being threatened or is dying. Higher number of three females represents a thriving population.